Okay, this is Summer Song, and today I'm going to give a little demo of Fishnet rendering and how it can be useful. So here, this is a prototype that's being rendered right now, and as you can see, if you know what a brain looks like, this is sort of the bottom half of the brain. This is the temporal lobes here. This is the cerebellum here, and this is the sort of the bottom half of my brain, and this rendering method would increase it slice by slice. If you could, it's parallelized, so if you had a lot of computing resources, it could be done quite quickly. If you have a little less, then it'll go a little slowly, as each slice would have to wait for the next one to be done. If you don't have sort of a cloud computing environment or some way to run several processes at once. This was being done using GPU accelerated computing, so that will definitely make it faster. And the more GPUs you have, the quicker you can render it. And I'm sort of just twirling it around here so you can see how the brain looks when it's rendered in this way. You can see the cerebellum here. And what's useful about this technique is that instead of rendering surfaces, it actually renders the whole brain. So usually when you look at 3D renderings of the brain, you'll see slices that cut through a surface model. The surface model being you can make it on the outside of the brain here, or maybe you'll make tracks for the DTI tracks. In that case, you would need an extra scan called DTI scan, which you don't get in clinical settings. That's really in research settings or to make pretty pictures. So you're pretty limited. You can do the overall brain in those slices, and that's usually what people do. But that might not necessarily give you a very good picture of the 3D dimensions and the 3D spatial relationships that are going on in the brain. This one has some downsides. It's a little bit blurry and hazy. You have these Mori effects that will actually get less if you look at this in a mixed reality environment because you have stereoscopic vision there, but we're making a video here so that we're limited to sort of this flat screen here. A relatively lower resolution screen. But anyway, it does still see the point where you can see the whole entire 3D structure of the brain of this multidimensional brain image using this rendering technique, which is patent pending and soon will be patented. So one other benefit to this, it can combine with slices and surface models, so it just gives sort of an extra information. Hopefully it would be very, very useful for radiologists. I'm just going to pull up sort of an older model to show you how that might be. This older model, it's not as good, as I made some changes, but it has some advantages as well, because well, it's just that it's done. I'm making this video in a hurry, or else I would pull up one of the newer models that had the same features as this older model. Pretty much the good thing that you can do is that you can plot multiple volumes on top of each other in this mixed reality 3D space, which is something that other methods don't necessarily allow you to do. You can combine several surfaces together, and they're all transparent, but if you ever look at sort of a model like that, I should have an illustration here. I will in the next video, but if you look at something like that, it's very hard to see the spatial and 3D relationships when you have just a bunch of surfaces plotted with different transparencies. But you can see here, this is sort of an older model, so the brain's not as good. But what I'm going to do right now is I'm going to add sort of this volumes on top of it. In this case, you can imagine this was a tumor, or you can imagine that it might be a brain lesion, or it could be an underperfused area of stroke. It could be another entire brain scan, and it's plotted in a way that you can see it at the same time as the other one. I call that cross-hatched fishnets, and it's a neat trick to do. In this case, we have the hippocampus plotted and the caudate. These are just areas of the brain, but you could do this with the whole brain, whatever area. And the cool thing is that you can also you could put these inside each other. They could be plotted orthogonal to each other so that you could see all of them at the same time. And so this is how this could be very useful for a clinician. All right, thank you very much. I will put up a better and more updated video in a later segment.